everyone. I'm Amir, a PhD student at the University of Toronto, and my supervisor is Professor Tamer El-Diraby. And today I will gonna presenting my research on adopting automation in peer manufacturing. And we've used a two-mode network analysis to identify the most influential factors and roles in this adoption. So as we all know, construction industry is one of the greatest contributors to GDP and employment throughout the world. And as you can see in this picture, the contribution of construction industry to GDP could be up to 13% in some countries. And it's one of the greatest consumers of the natural resources. And despite this greatest contributions that it can make, there are some challenges in this industry. Like we need to optimize the resource consumption, and also we need to reduce the amount of waste that is being produced by the construction activities. And it's, as you know, it's always lags behind the other industries in terms of adopting new technologies. So one of the approaches, one of the solutions to kind of these problems has been the prefabrication. This approach has been introduced, and there are lots of research on the benefits of this approach, like the quality improvement, the faster speed, the reduction in cost and waste, and the help that it can make to the sustainability. But it also has some challenges. Like in the construction industry, we have every project has its unique requirements. So it's very difficult to make the prefabrication generalized to make it applicable to all the requirements of all the projects. And also we have a wide range of different stakeholder compositions in construction industry. So architects, engineers, contractors have their own opinions. Uh, so, but there is a lack in investigating the automation in peer manufacturing. So um, it could be a promising approach to mitigating some of these challenges. Uh, so in this research, our objective is to investigate the potential of automating the prefabrication. The focus of our work is in the delta between the manual pre-manufacturing, where the workers construct the building sections at the manufacturing, and the automated mode, where the robots can do the same. And the context is Iran as a representative of a developing country, and North America as a representative of a developed region. And the breadth of this research, we are investigating the different factors, and we use Iran and North America, as I said, to incorporate as much factors as we can. And the breadth is technical, business, economic, and environmental factors that could be important and influential. And we use the two-mode network analysis. So we technically distributed surveys to the experts, but instead of like asking them which factor is more important, like quality improvement or profitability, explicitly, we asked these kind of questions implicitly, like, do you think that there is a relationship between these two factors, or other kind of similar questions? And we analyzed the answers, and we built networks based on their answers, and we kind of look at the different definitions of importance. So using the network measures, you can have another look at the definition of the importance. So I will talk about this in the subsequent slides. Some of the factors that we investigated are like parallel production, design customization, resilience, foreign markets, unstable condition, diversification of workforce, to setup time, maintenance costs, and even environmental factors like GHG emissions. And we distributed a survey to the experts in Iran and North America. And here are some demographic profile of respondents. As we expected, for example, the familiarity with peer manufacturing in North America is way more than the people in Iran, as you'll guess that. And here is the adjacency matrix that we used, that we developed based on the surveys. So for example, in the first column, we have the roles, and the first row, we have the factors. It says that, for example, the row number 8, which is which could be like a university professor or a project manager, has voted for the existence of relationship between factors 12 and 13. Um, and here are the developed or created networks for Iran and North America. As you can see, the network of North America is a more complicated network that could be a sign of a well-established and mature industry. And the network measures that we used are degree centrality, betweenness centrality, and eigenvector centrality. For example, by using degree centrality, you can identify the key influencers in your network. Betweenness centrality will help you to identify the nodes that control the flow of information. And eigenvector will help you to identify the nodes with influential connections. And here are some of the results. For example, in Iran, the profitability is the most important or influential factor, but in North America, like efficiency is more important. And we have some environmental factors in North America, but we cannot see them in Iran. And here are some of the most influential roles based on our data. I will talk about some insights here. It's very important to consider the regional priorities and differences when you are talking about adopting automation in manufacturing. For example, Iran is on its survival mode, so profitability would be the most important factor here when they want to incorporate the automation in manufacturing. And its focus is on foundational economic and operational efficiencies. But in North America, you can see that there is a holistic approach to balance the sustainability and productivity. And for example, in Iran, the focus is on profitability because there are unstable conditions and the initial costs are very high for Iranian industry parties. But in North America, they are more focused on incorporating diversification of workforce or environmental factors. And for the important or influential stakeholders, for example, in Iran, we found out that the university professors are among the most influential stakeholders. But why? Because the industry is not that advanced in Iran, but university professors are usually working on the cutting edge technologies. So they can help to introduce the benefits of the automation in manufacturing to the industry. So they can kind of convince them to like implement these new or advanced approaches. And for some of the other insights from our approach is that, for example, for the policymakers in Iran, if they want to promote the implementation of automation in manufacturing, they should focus on economic incentives and stability. But in North America, they should promote diversification of workforce, or, for example, they should support the sustainability and workforce development. Um, Thank you very much. I just want to acknowledge that we received partial support from the MyTex and the Promise Robotics Incorporation based in Canada. And thank you very much for your time.